Welcome to another video on my driving robot Discovery, based on the fischertechnik TXT controller running embedded Linux, equipped with two front sensors, active sonar, ultrasound, an LED for indicating sudden changes and distances, a propeller on the back to indicate that the algorithm is still running, and two encoder motors, one for each side obviously. Originally it was intended to use OBCV, but due to a kernel change the camera does no longer run on it, and so far I have seen no changes that it will run. So I depended on the front sensors and the sonar to detect those two objects and possible other objects. Bound for 60 centimeters distance. Let's immediately make it 60 centimeters, which makes it go here. And from that distance the whole of the algorithm should work. And first of all, before doing anything and introducing the desktop again, I have to boot it. So let's see for the boot sequence if that all works out, and then start an experiment, however it may turn out. Alright, so with the camera pointed at the as close as possible on the robot, I first have to connect the battery. I hope it has enough power. Power up. And after power up I can do some tests. And it looks like going alright for now. Going to the standard interface, because that is what I need. Right there. Now I can try to log in, and that's a problem. Okay, it has come by, that is good. So now this will be the coder. Naming, of course, coder. And here I will do anything like output. And run anything. Let's first, now I'm just going to do that. So moving the camera right here at 60 centimeters. Let's see how it works out. Oh, and it should ask for difference, which it doesn't. Oh, and there it goes. Right. So that obviously was not quite the idea. On the other hand, alright, let's quit. On the other hand, here, no, not that. I need to view data. 0, 0. I don't really care about that one. 340, 322, 315, and it drives nicely. Battery, ooh, that is very close to 8, so it may not hold very long. Oh, there it is, 8.2, so yeah, in the dangerous zone, 7.8. I may have to replace it soon. That's not what I want to look at right now. Right, let's go to the end then. Distance left, 80. It's all 80. And that is part of the problem. Counters are not equal. No, because it can't be equal now. It made the left side turn. But even that, the distance doesn't go below 80, and that's strange. Why not? Anyway, before anything else goes wrong, let me grab the adapter. Right, next attempt. Measure distance to the object is 60 centimeters again. And now it is connected via power supply to the net. So let's see how this one goes. Which goes different, entirely different. And here's a strange thing, that it presses against the switch, I think, but it doesn't stop, and it keeps saying 11 centimeters. Alright, and now what I want is RoboPro. And see if that switch actually got activated. So first, that's the good one. And did it activate? No, it did not. There's no sign of any input here. And yet it is pressed. So, and now it is pressed, but it wasn't pressed, which explains why it kept on going. So let's go to the data again, to the end. Distance left 20. That's not good. That's no good. Yeah, it's not equal, which is logical. Counter 0. Oh, come on, distance 0. No, 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 no. This really doesn't make sense, any sense at all. So how it does get it values, I don't know. Is my algorithm that wrong? It could be, but I severely have doubts. Alright, let's run it once again. Measuring 60 again. Yeah, even more than 60, but that doesn't matter. Doesn't really matter. And let's go from here with power cord. Go. And there it goes with a clear deviation. And it stops. It has a full stop. And it doesn't touch anything. But is this then the sonar? Closer than 4. Yeah, okay. Car horn short. Yeah, I did hear that. So that's closer than 6. Between 6 and 10 actually. Distance is 1. Distance is 5. And that's the distance measured. Yeah. Distance left is 53 by the way. And 48. And 47. So in that perspective, it doesn't make sense anyway. But this shows that none of the tries of the algorithm are the same. None of them. So next thing that I want to do is modeling with Blender, also with this one. Just see how the thing is already modified or actually constructed. And whenever I have to modify something, I know how it was. So let's go there. Alright, so with Blender I am just starting modeling it, and since this is the real model in centimeters, everything is 1.5 centimeters, something like for a block. I have now put everything to metrics, and this is actually everything in everything the way it should be. So now let me, it is unfortunately transparent. I pressed something and it became transparent, so I have to do something somehow to make that undone, but for now let's duplicate. And since the real thing has 1, 2 small blocks and then 1, 2, 3, 4 long blocks, I actually should select this one and shorten it like this. Next, same thing, move against, and then another one, duplicate, and scale that. And why does this work not so nicely? That goes better. Is this twice as long? It is twice as long. Alright. That's better. Duplicate this one. And then yet another one. Then I have to duplicate. That is 1, 2, 3. And then a short one, where actually an axle will go through. Then another one of this. And that's one piece, that's one side. So now if I manage to select them all and say duplicate, then it is absolutely not the same anymore. Not to mention that it doesn't make any sense. Up, up, this one goes up and this one goes up, and even although too transparent, but it does show how it should, what it should look like. And that's also the problem with three-dimensional stuff. You'll have to align everything and then of course bring it down, because it's not far enough and not down enough. And how far should it be? And then let's go here again. It is 1, 2, 3, 4 blocks. So duplicate and then rotate, but not like this. Look at that. And I have to actually rotate it, but not like that. How do I rotate it over its y-axis? Have to find that one out. This accidentally looks like something anyway. Duplicate, another duplicate, and another duplicate. And now this won't look like anything, but at least I will have a little bit of the measurement. So now I can select this, bring it all down, but also bring it at the right distance, which should be here somewhere. And down, and right there. This should be it. With this of course corrected, and then I have the front part of this stuff, not yet this. So this could be something. Let's now save it before something bad happens. And that is of course not this one. Yeah, and this is of course discovery.land. And save, and there it is. And this is the start of the making of a model of the discovery.